This lesson today is about the quadratic formula and also the discriminant. First of all, some of the information in this is a little bit outdated. So one thing is it says it can be found in the textbook on these pages. Cross out those pages. Those were the old textbook. Our new textbook is the Big Ideas textbook, and they are on pages 122 through 126 in the Big Ideas textbook. If you don't remember how to get to the Big Ideas textbook, I have that information over here. So you go to bigideasmath.com, you log in with Clever, you click on the ebook, and then you get to pages 122 through 126. And on those pages, they will show you some examples, and they will probably have some videos also to explain how to do it. The main part of the lesson today is on the quadratic formula. This is a formula that you do need to memorize. And to help you memorize that, I do have some songs for you to learn. Some people, I think, maybe learned it by a song of Frere Jacques, but we are going to do Pop Goes the Weasel in this class because that's the one that I know. But we can go over both of them. I mean, I've got some videos that I can show you on each of those. Before we get to the full quadratic formula, let's talk about the discriminant. Well, first of all, what is a discriminant? So over here on the left, the discriminant is what's under the square root. Anything under the square root is called the discriminant. Well, what's under the square root? Under the square root is b squared minus 4ac. And that will tell us how many solutions there are. And you might want to write that down. That's kind of messy, but it tells us how many solutions there are. So that's the reason we look at the discriminant, is that if you are thinking about what you're doing, you can look at the discriminant and decide immediately if there are one solution, two solutions, or no solutions. Well, how do we do that? Well, the fact that they are square roots, I think we all know that if you try to take the square root of a negative number, thus far, there is no square root of a negative number. Now we will change that rule here in a little bit, but right now there's no square root of -2, and so that means there are no real solutions. If it is equal to 0, well, the square root of 0, how many are there? Well, there's only one. The only square root of 0 that there is 0. So if there's square root of 0, that means there's only one solution. Well, what if it's a positive number? Well, if it's a positive number, there are two solutions. For example, 16 means that the square root of that, you could have a -4 or a +4. And if it is 5, now it's going to be some random decimal, but it's going to be the positive answer of that decimal and the negative. Okay, let's look at an example of a quadratic. As an example, I'm actually choosing a problem that we could factor it, but I'm choosing it because it's going to be a little bit simpler to do with the quadratic formula, just to start off with one that's a little bit easier. So that's why we're doing that. Okay, the first question over here on the right says, what is the value of the discriminant? Okay, well, let's go back and remember. Remember, this first number is our A, the second number is our B, and the third number is our C. In this case, A is 2, B is 1, C is -15. The discriminant is b squared minus 4ac. And so if we plug in b is 1 minus 4 times a, which is 2, and c, which is -15. If we work that out, 4 times 2 times -15 is 120, and we have two negatives in a row, so that makes it a positive. So 1 plus 120 is 121. So the solution, the discriminant, is a positive 121. And we might emphasize that as a positive because that's what the whole point of the discriminant is. We're just looking at, is it a positive number, a negative number, or is it 0? And so sometimes when that question comes up, you might not even work out the whole thing. You might just be able to look at the signs and kind of figure out generally and realize if it's positive, negative, or 0. Okay, if it is a positive, which it is, how many solutions will there be? Well, we look back at our rule, and I know in my head that 121 is actually a perfect square. There are two solutions because it is positive, because we can take the square root of positive 121. Let me go back a minute maybe and talk about why that is 2. And so if you look at the formula has this plus and minus. And so if it comes up with an answer, as this one does, you're going to be taking, like this is 11, you're going to be taking whatever negative b is plus 11 and negative b minus 11. And so that's where we're getting those two answers from, because one of them is plus that answer, one of them is minus that answer. Okay, so that is how to do the discriminant. The quadratic formula is a little bit longer. So for the quadratic formula, we start off with x equals the opposite of b plus or minus the square root of, and so we make our big long square root sign, b squared, which is 1 squared, minus 4 times a times c, and a is 2 and c is negative 15, all over 2a. All right, just a minute ago, we figured that discriminant part of it to be 121. And so now we can solve this. And you can do it on your calculator. You can do this whole thing starting from ground zero on your calculator. Or what I'm doing is I'm doing it kind of in my head along the way. Either way is fine. So if you're doing it this way, square root of 121 is 11. So I have a negative 1 plus 11 all over 4. And I also have a negative 1 minus 11 all over 4. And so now I put both of those into my calculator. This is 10 over 4, which is 5 halves. And this one is negative 12 over 4, which is negative 3. And so as it turns out, we could have factored it. And the reason I know that is that we have rational answers. And so we could have factored it, but we ended up just solving it by quadratic formula instead. And so those two solutions are the two solutions to the problem. Now let me tell you something, is that you could, instead of doing factoring on almost anything, instead of doing factoring, you could do quadratic formula. And I have students from time to time who do that. Let me just warn you that the problem with that is time management. That if you are only doing the quadratic formula and you are never factoring, it is going to take you much, much longer. And on a test, I'm not going to allow you that extra time. So yes, the quadratic formula can be used anytime, but I do think that you ought to stick to factoring when it is possible to factor so that you are saving yourself a little bit of time. Okay, the last thing would be to write in some things into the summary. And so you might discuss what does the discriminant mean. You might discuss, something about positive and negative signs. Whatever you want to write down there, write down something into your summary. We will continue to work on quadratic formula in class, and I'll try to come up with some examples that try to cover all these different situations of when is it positive, when is it negative, and so forth.